الله الجليل. بسم الله الرحمن الرحيم. الحمد لله رب العالمين الرحمن الرحيم مالك يوم الدين إياك نعبد وإياك نستعين اهدنا الصراط المستقيم صراط الذين أنعمت عليهم غير المغضوب عليهم ولا الضالين. Allah الجليل. Again, we are indebted to God for giving us this opportunity, and this is by divine design that we are here, and so we should be grateful to God for including us in this beautiful occasion, and we should make sure that we always are grateful to our Lord, and so we have to go through this endeavor and make sure that we understand this, that the source of everything that we have is from God, and we have to be thankful and grateful. Gratefulness is a godlike quality, and we have to follow the path of God and reciprocate and make sure that we are also grateful to God, because He's always grateful to us. Today, what I wanted to talk to you about is, I want to go through the old mathematics, and the reason for it is that I want these things to sink in and be explained to people. So this is actually from a short few slides that I made for Mahmoud, and he put it on his YouTube channel. And but anyway, so I want to go through it, and it has recordings on it, but I don't want to play recording. I just want to go through this slide by slide, and so we can understand it better. Mersenne primes. Mersenne primes are the form of MP 2 to the p minus 1, and the p is the exponent of 2. And the list of some Mersenne primes with their indices are here in this table. And I want to just make sure that it's understood. P is the exponent. So it's 2 to the 2 minus 1. 2 to the 2 means 4. Means you multiply 2 by itself twice. And so that's 2 times 2 is equal to 4 minus 1 is equal to 3. So 3 is the first Mersenne prime. And then 2 to the 3, again, you see 3, 2, 3, and 5, and 7, and 11. They are 13. They are all prime numbers. Okay, so 2 to the 3 means 2 times 2 times 2, which is 8. Minus 1 is 7, so 7 is the second Mersenne prime. And 2 to the 5 is 32. That means 2 times 2 times 2 times 2 times 2, 5 times. And so that's minus 1, that becomes 31, and so on. 2 to the 7 is 128. Minus 1 is 127. So that's the fourth Mersenne prime, and so on. So we just keep doing this until we get to the 90th. So we could do this in our head, basically. So these are doable by hand. These low Mersenne primes, these small Mersenne primes, are doable by hand. So now when you get to the 19th Mersenne prime, which was discovered in 1961, okay, and this one by Horwitz, and this one had to wait for electronic computers to come into the scene. Otherwise, you cannot do this. So the exponent of the 19th Mersenne prime is 4253. So why did I go to 19? Because Quran tells me to go to 19. Okay, so that's where 4253 comes from. Okay, so when you do this, that means now you have to multiply 2 by itself, 4,253, which is impossible to do by hand. So you have to have a number cruncher. They used to be called number crunchers. Okay? Computers used to be number crunchers. That means they just crunch numbers, and they multiply, divide, and all those things that you couldn't do by hand. It was just too long and tedious to do it by hand. So that's what we did. So at that time, it was discovered, basically, this one discovered in 1961, November of 1961. And comes to this, that the exponent of the 19th Mersenne prime, as I said, is 4253, has this unique property that chapter 42 also has 53 verses. Okay? So if you go to chapter 42 of the Quran, you immediately see it has 53 verses. So that's where the 4253 comes from. So the property of the Quran with the chapter 42 having 53 verses means that it had to obey that mathematics. So in other words, the mathematics generated chapter 42 having 53 verses. Okay? Which, now, there is something which is very peculiar about chapter 42. Chapter 42 actually has two sets of initials. It's unique in the Quran. No other chapters in the Quran has two sets of initials. It has Hamim, Ain, Sin, Qaf. Okay? So now if I go down, then I'm going to look at the properties, the permutation group properties of 4253. Okay? I can write, there are 4 consecutive digits, 2, 3, 4, 5. If I start from 2, 3, 4, 5, which is the first group element, I can generate 24 of them. It's basically 1 times 2 times 3 times 4, which is 24, called the 4 factorial in mathematics. Okay? Some of these stuff are difficult. Okay? Some of these stuff, admittedly, they are difficult, so you have to learn a little bit about it. Okay? So if I look at the group properties, permutation group properties of 2, 3, 4, 5, I notice that chapter 42, which has 53 verses, which is 4253, is actually the 14th group element. Now, I highlighted all of the numbers here for a reason, and you see it in a minute why I highlighted those in red. See here that the permutation group properties are 4253. The 19th group element in the last slide that I showed is actually 5234. And it happens to be the 4537th composite. And chapter 45 in the Quran has 37 verses. Now remember now that chapter 45 is also one of the Hamim initial chapters. The 22nd group element happens to be 5342. And it is actually the 4635th composite, and chapter 46 has 53 verses. Okay? We would not be able to do this before 1961 because this one was not discovered. The 19th Mersenne Prime was not discovered. Okay. Now, furthermore, the group element 9 is 3425, and it's the index of composite 3975, and Surah 39 has 75 verses. Also, we know that chapter 39 in the Quran has a unique property. It happens to be the 19th uninitial surah in the Quran. So if you count all the uninitial surahs from the beginning of the Quran to chapter 39, you notice that chapter 39 is the 19th one. Okay. Group element number 10 is 3452, and it is the 2969th composite, and chapter 29 or Surah 29 has 69 verses. Okay? Can you imagine that? Okay, so permutation group properties of 4253. We furthermore note that the 15th group element is 4325, and it is a tri-prime. And the index of the tri-prime 4225 is 1103. And we know that Surah 110 has 3 verses. Now, remember now, Surah 110 is the last revelation of the Quran. Surah 110, which is a very short surah, only has 3 verses, is the last revelation of the Quran. So in the order of revelation, it becomes 114.3 or 1143. And 1143 actually is 9 times 127. Okay. 4253 Gaussian prime happens to be 87407, and the 11/21st individual twin Gaussian prime is 87407, and we note that the number of frequencies of Hamim in surahs 40, 41, and 42. Remember now, we started the chapter 42. Okay, so the number of Hamims in 40, 41, 42, 40, 41, 42 is 444 plus 324 plus 353 is equal to 1121, which is 19 times 59. But now, 19 and 59 are both prime numbers and are the 8th and the 17th prime number. And 817 is the frequency of initials in chapter 31. If you count all the Alif Lam Mims in chapter 31, there are 817 of them. Okay? That amazing? Okay, so from that 19th, the exponent of the 19th Mersenne Prime, this is what we ended up at. Okay. Now, again, we further study this one. 5324th composite happens to be 6123. 6123 verse from the beginning of the Quran is 9619. Remember now, chapter 96 is the first surah that was revealed. We just studied the last surah that was revealed. Now this is the first surah that was revealed. 96, Al-Alaq, the embryo, is the first surah that was revealed. And so 9619 would be what? Would be the 19th verse that was revealed. Okay. So stay tuned. So now, remember now that all of these things that I said is coming from 4253, the exponent of the 19th Mersenne Prime. This is how Quran was generated. Okay? We didn't know these things before. We had no idea about these things. These things came later on to us. So instead of counting the number of initials in chapter 31 or chapter 42 or chapter 43 or chapter 44 or chapter 45 or chapter 46, the number of verses in these chapters, okay, we are doing it the other way around. We're actually generating, we're telling people why they're supposed to have those number of verses. By the way, this 4253 is only for the Hafs version of the Quran. It doesn't work for the other one. The Warsh version of the Quran has, chapter 42 has 50 verses, because the way they structure the verses is not correct. This tells you which one is correct. Which version is correct. That's what it's telling you. We had no clue about these things. We just picked one version and we said, yeah, this is it. That was not it. There are a lot of different versions of the Quran in circulation. And the number of the verse structures do not match. So this is telling us which one is the correct one. Okay. This is by the virtue, as I said, because God said over it is 19. This is by the virtue that the 19th Mersenne Prime, the exponent of the 19th Mersenne Prime is 4253. Okay? This is how it's done. This is how Quran is generated. So we won't have any doubt that what we are reading and the way we're stopping at verses is correct way of doing it. So it's a, as I said, these things, generating these primes are time consuming. So So what is the probability that this is a fluke? That this is just a random thing that people did, okay? And it just happened to be that 19th is like this, okay? Well, we can actually go to the Mersenne primes, type in our Google search box, go to Mersenne Prime, and go to wiki page. I said before, you go there, and it says list of known Mersenne primes. You click on that, and it says right here is a blue list of known Mersenne perfect numbers. So we go there, and here it is, and these are the Mersenne primes. So we scroll down to 19. Okay, 19 is this one, 4253. The 20th happens to be 4423. Why is it chapter 44 doesn't have 23 verses? Think about it a little bit. Okay? So this probability is zero. Because this is a deliberate thing, and I show you why, okay, in the second unit of this one. Why this is supposed to be actually 19. Why is it supposed to be overhead is 19? Okay. And the interesting thing is that both of these numbers, 19 and 20, they were both when in November of 1961 and Alexander Horwitz. That's the discoverer of both of these numbers, 19 and 20. Okay. Why was it? See, between 3217 and 4253, there are 1,000 numbers. Usually about 10% of them are prime, about 100 prime numbers. But none of them happen to be a Mersenne prime. Doesn't work according to the formula for Mersenne prime. So just one of them works, and that just happens to be 4253, and happens that chapter 42 has 53 verses. Okay. So with this, we're going to go ahead and thank God and finish this unit. الله الكبير سبحان ربي العظيم الله الكبير الله الكبير الله الكبير الله الكبير سبحان ربي الأعلى الله الكبير الله الكبير بسم الله الرحمن الرحيم الحمد لله رب العالمين الرحمن الرحيم مالك يوم الدين إياك نعبد وإياك نستعين اهدنا الصراط المستقيم صراط الذين أنعمت عليهم غير المغضوب عليهم ولا الضالين الله الكبير Okay, very good. Okay, so now it's going to get a little bit more complicated. Okay, so now we go to Gaussian Mersenne primes. Now these are the numbers that are, instead of having 2 to the power p, they are 1 plus I, where I is the square root of -1, and this number is a complex number. Okay, so they are a form of 1 plus I to the power n minus 1. Okay, so this is a ring of integers that have this property. Now, if you multiply this number, once you get 2, once you raise the power 2, and all of those ends, they have to be prime numbers, 2, 3, 5, 7, 11, 19, 23, and so on. Okay? But they always do not give you a prime number, which means that this ring of these integers, when you multiply by its own complex conjugate at the very end, which gives you the norm or the magnitude of that number in real domain, in real number domains, domain of real numbers, that number becomes a Mersenne prime. I'm sorry, becomes a prime number. Okay? Like 4 minus I. See, 4 minus I is a Gaussian Mersenne prime. And if you multiply by itself, 4 minus I times 4 plus I, you're going to get 17. 17 is a prime number. It's actually a Gaussian composite. We call it a Gaussian composite. 17 is a Gaussian composite because it's factorizable in the domain of Gaussian Mersenne primes. Okay? So, when we do this, when we do all of this said and done, then you're going to get rational numbers, 5, 13, 41, 113, so on, and they get very big very fast. Again, in the previous one I talked about that it was done in 1961. These are this century's findings. Okay, so we'll go down a little bit and we'll find out that when I made a table here, just like I did for the other one, okay, and we notice that the exponent of the 19th Gaussian Mersenne prime is actually 353. Okay, that means that I, or 1 plus I, close parentheses, to the power of 353, then you subtract 1 from that. That will give you a number. When you get the magnitude of number, it becomes a real number, and that's a prime number. That's a Gaussian Mersenne prime. And that happens to be 353. That exponent happens to be 353. Okay. Now, as I said, the exponent of GMP or Gaussian Mersenne prime is 19th one is 1 plus I to the 353 minus 1. And the exponent of the 19th GMP happens to be 353. The number of frequency of Ha plus Mim in Surah 42 happens to be 353. Okay. So first we generated the number of verses in chapter 42, which happens to be 53, with the 90s Mersenne prime. Now we are generating the number of frequency of Ha plus Mim in that chapter, in chapter 42, with the Gaussian Mersenne prime. Okay, 353. Okay, so if I go a little bit, and I have this from Rashad's book, okay, Visual Presentation of the Miracle, Rashad Khalifa, 1982. Okay, and as you see here, the third one, 42, happens to be 353. That time we had no clue. Why 353? Because if you look at all of those counts, all the counts of Ha Mim in that chapter, chapter 42, okay, chapter 40, chapter 41, 42, 43, 44, so on, up to 46. If you count all of those, they are all composite except for 42, which happens to be a prime number, 353. Okay. And as I showed you in the previous unit of this prayers. If you add those up, 40 plus 41 plus 42, the number of Hameems in those chapters, they add up to 1121, which is 19 times 50, 59, which has a further thing based on prime and their indices, which is 8 and 17, and 817 happens to be the number of Alif Lam Meems, or frequency of Alif Lam Meem in chapter 31 in the Quran. So now remember that I told you that they produce a Gaussian composite. When you get the modular of this, or you get the magnitude of these numbers, which is a real number, a real domain, rational number, you're going to get a prime number. Okay. So here we have Gaussian composite. It becomes a Gaussian composite, like 17, for example. 17 is a Gaussian composite that you see in this table. It's a prime number, but it's a Gaussian composite because it's factorizable in the domain of the complex numbers. Okay. So when you do this, then you're going to get this table here. And we notice that 209th one happens to be the 422nd regular prime, and it's not 2917. Okay? And so we study this a little bit further, and we notice the following. Okay. We notice that 209 is the total frequency of Ayn Sin Qaf in Surah 42. Okay. Note that Ayn Sin Qaf is mentioned in chapter 42, verse 2, Hafs version only again. Okay. So Ayn Sin Qaf has to be a separate verse. It happens to be the second verse in chapter 42. Okay. Thereby you see 422 there. So 209 lines up with 42.2. Furthermore, 2917 is the 11th permutation of 1279, and the 19th permutation of 1279 is 9127. So we have 11 and 19, but 209 happens to be 11 times 19. This tells you why it's supposed to be 11 times 19. See? Back when we were introduced to these things, we were happy with the fact that Ayn Sin Qaf, the number of frequency Ayn plus Sin plus Qaf, in chapter 42 added up to 209, and 209 was a number which was divisible by 19. We were just happy with that. This tells us how it's generated. How it's supposed to be 209. Why it's supposed to be 209. Because it has the property that tell you also when Ayn Sin Qaf is going to be in the Quran, literally, in chapter 42, verse 2. It also tells you that 9 has 127 verses. That's why it's 11 times 19, because of the permutation group property of this. So what does the permutation group property have to do with the prime numbers? Okay. Then you need to know a little bit more advanced math. God is not going to stop here because we don't know things. He's not going to quit giving information to people because we don't know it. And so we are basically exempt from learning that because we don't know it. But he shows the beauty in it and simplicity with things that we actually understand. Okay. Such as 11 times 19. Okay. Going the wrong way. All right, so I have 3 versions of the Quran. And as you see, On the right side is the Hafs version of the Quran, which is Hamim as verse 1, Ain Sin Qaf as verse 2. The other ones combine the two together, the Wash version and this unknown version that I have here. They combine them together, which means that is not correct. This mathematics, 209, 422, 2917, tells you why it's supposed to be chapter 42, verse 2, Ain Sin Qaf. So it tells you only the Hafs version is correct. The Wash version and the other version, which is unknown, and there are other ones too that I don't know about, but it doesn't matter. As long as they are bundling those up together, Hamim and Ain Sin Qaf, they do not belong to the structure which is enforced by the mathematics, which is generated by mathematics. Okay. Now, furthermore, 209 is the total frequencies of Ain Sin Qaf in Surah 42. Know that Ain Sin Qaf mentioned in 42.2, Hafs version only again. Now we focus on the indices of 209 and 422. We realize that both 209 and 422 are semi-primes, and they happen to be the 68th and the 133rd semi-primes. But chapter 68 in the Quran has 133 noons in it. Again, that's a mistake in all of the Qurans. The spelling of the noon is supposed to be noon, wav, noon. You cannot just say in, noon, because that makes it 120, 132. This tells you it's supposed to be 133, according to this. According to the fact that chapter 42, verse 2 is Ain Sin Qaf. This comes directly from that. Okay. Now we know why. Now we know why. So what is this doing? What is this mathematics doing? It's actually correcting the counts. If there are a flaw in the count or misspelling in there, it actually shows it to you. And this is, my friends, this is just the beginning. There are a lot of other stuff that we do not know, and the mathematics is not really known to us at this time. And we don't know, I don't know what's going to be in the future, but this is just the beginning of this. Okay? And that's the beauty of the Quran. Because it's driven by the mathematics that these mathematics are completely unknown to us. I just told you about the thing about the factorials or the permutation group property, and what does that have to do with prime numbers. And again, you have to know a little bit more math to realize it, okay? And this is another thing that I want people to pay attention to. Sometimes, because of ignorance on our part, what we do is we reject things because somebody tells us, or we are fascinated with somebody, or we respect somebody, and they tell us something, we just blindly admit it, okay? And that's a dangerous thing. So we have to be careful. Okay, so let me just go over here and I'm going to introduce you to something called Stirling's approximation. I didn't know about this until 2015. Somebody told me in a conference. when I was showing my prime numbers and cross sections of neutrinos, somebody mentioned to me, he says, oh my, that looks just like the Stirling approximation. This is Stirling approximation. Log of n factorial is equal to n log of n. So, this one can be also approximated as this left part of log of n factorial. Okay. The number of factors like 24, for example. Okay. Or 4 here. N is 4, this becomes 24. Log of 24 is a prime number, and that's equal to n log of n. Okay. Which this n is the index of that prime. And so when I wrote this gentleman said, oh my, that looks like Stirling's approximation about the prime numbers. So you see why those 4253 has to do with what the idea of permutation group properties of 4253 and how those generate versus in other chapters in the Quran. In the Hamim initial chapters, in 29, chapter 29, recall now chapter 29 also stands for what? For the fact that surah, number of initial surahs in the Quran is 29. Okay? The 29 is supposed to have 69 verses, 39 is supposed to have 75 verses, and chapter 39 happens to be the 19th initial surah in the Quran. This is the magnitude of this idea that I'm trying to transmit to people. Okay. So here, as you see, it has the n factorial itself, and then it has gamma. This is also advanced math. I don't want to get into it. Okay. And this line is the Stirling formula, or Stirling approximation, as you see here, the red one. Okay. So for small ones, it's not good, and then it goes up, becomes more and more. Comparison of Stirling's approximation with the factorials. Okay. All right. So I'm going to stop here and finish our Jum'ah. Allahu Kabir. سبحان ربي العظيم الله الكبير